Welcome to lesson 1 of 2 in this tutorial, covering the poles of a magnet. This is the first video in our series of 2 lessons on the topic of magnetism. Here are the key learning objectives for today's lesson. First, we will look at magnetic forces, then at exertion of forces, and finally at producing magnetic fields. Here are the AQA specification points for today's lesson. Feel free to pause the video now and have a quick read through them before we begin. We'll start off with the poles of a magnet. Magnets are capable of creating and exerting forces. These are called magnetic forces, and they're produced due to a magnetic field. Every magnet will have 2 poles, a north pole and a south pole. These are the places where the magnetic forces will be the strongest. You need to be able to understand the terms magnetic force and magnetic field. We'll be referring to them quite a lot in this section, so make sure you know what they mean. We have just seen that the poles of a magnet will exert a force. When we place the poles of 2 separate magnets next to each other, one of 2 things will happen. We'll either get attraction or repulsion. You need to remember the following statements. They're quite important. Like poles will repel. If we place 2 north poles next to each other, then the magnets will experience forces of repulsion. Therefore, these magnets will move apart. The exact same thing happens when 2 south poles are placed next to each other. They will repel. You also need to know that unlike poles will attract. If we place a north pole next to a south pole, then the magnets will experience forces of attraction. This means that the magnets will touch and will join together. You need to remember that like poles repel and unlike poles attract, since AQA exams often include 1 or 2 mark questions regarding these statements. Now let's look at the next couple of learning objectives, attraction and repulsion. Magnetic forces can be described as non-contact forces, since they do not require the objects to touch. Previously, we saw another example of non-contact forces when we looked at electrical charge. Attraction and repulsion occur with permanent magnets, and they are examples of non-contact forces. You may be asked to describe what happens when a student places the poles of 2 magnets next to each other. Read the question carefully, noting down the poles of each magnet to make sure you don't make any silly mistakes. Now we will cover permanent and induced magnets. We'll be looking at magnetic fields, types of magnets, and induced magnets in this section. When we have a magnet, it will produce a magnetic field. Permanent magnets will produce their own magnetic field, as opposed to induced magnets, which do not. We can have 2 kinds of magnets, permanent or induced, as we've just seen. Permanent magnets will always show magnetism. Induced magnets are slightly different. They only become magnets when they are placed into a magnetic field. Induced magnets will cause attraction. This means that they will attract other magnetic materials which may be close by. When we remove an induced magnet from a magnetic field, it will then lose most of its magnetism. In some cases, the magnet will lose all of its magnetism very quickly. You should be able to recall that induced magnets need to be placed in a magnetic field in order to be magnetic. As soon as the induced magnet is removed from the field, it will lose its magnetism. Finally, we will look at how to describe the difference between permanent and induced magnets. Let's fill in this table together to look at some of the differences. First, let's cover whether they are always magnetic. Permanent magnets will always be magnetic, whereas induced magnets are only magnetic in a magnetic field. Next, we'll look at attraction and repulsion. Permanent magnets can have both, whilst induced magnets only have the force of attraction. Finally, let's look at whether they can produce their own magnetic field. Permanent magnets can, but induced magnets cannot. Now let's try a practice question. Which of the following are characteristics of permanent magnets? Pause the video now to have a go by yourself before we go through the answers one by one. We know that A must be false, since permanent magnets are always magnetic. B is also false, since permanent magnets can indeed attract and repel other objects. C is true, since they are capable of producing their own magnetic field. D is false, since magnets can attract and repel objects as we described earlier. We've now covered all the specification points for this tutorial. Feel free to skip back through the video and re-watch anything you feel unsure about. We've now completed Lesson 1.